Welcome to our next week. Welcome to Spooky Science. Am I a ghost now?
Apparently so.
Am I a ghost
So,
now?
for our next experiment, our first one of week 2, we're going to be playing with magnets.
Yeah.
Okay, playing with magnets is a common introduction to science for most preschool age children. This experiment shows magnets in action with a unique twist, and this is one that we actually downloaded through Twinkl for their Halloween special resources. To start with, introduce your child to the forces of magnetism by allowing them to feel the pull of the magnets attracting and repelling. So Nimue, would you like to pick up both magnets?
This one?
Yep. Anthony, pass her that one too. And would you like to see which ends connect? So which ones attract?
This one. No, I said we don't. Let me try the other side. Both of them. So you try to do red and blue. Yeah. So, are you ready? So what I was suggesting to do was this. So, if it's the same colour, it won't connect. It has to be a different colour.
Well done, Anthony. So, the magnetic field also means that magnets attract and repel other items in the world around us. A magnet has two ends called poles, also known as the north-seeking pole and the south-seeking pole. The north pole of one magnet attracts the south pole in another. A north pole will repel another north pole, just as the south-seeking pole repels another south-seeking pole. And the saying is, like poles repel, unlike poles attract. So Anthony, you were completely spot on there. A magnet creates an invisible area of magnetism all around it, and we call this the magnetic field. Can you say that, Nimue?
The magnetic field.
Well done. So, we're going to use magnetism to make our witches fly.
Mum, I have an idea what happens if you wave it above. And let's see.
Well done.
We're making a change. I'm making a change.
So, the magnets attract the paper clips. You don't want to lose your paper clips because you need them for the next stage. So, what we're going to do now is stick our magnets to the back of our witches. So turn your witches over and position your magnets, and then stick them on with some sellotape.
Anthony just did.
I don't see it.
Are you showing him where yours, Anthony?
Look.
So you need to put your tape on the back of the witch.
Clever girl, Nimue.
And this is what my witches look like. I am flying low. I am flying on my broomstick.
Okay, so Nimue, shall we go first with you? Put your witch in front of the picture in front of you.
This one?
Yeah, so face it outwards. Prop it up. So Nimue, now get your magnet and put it behind the cardboard.
This one?
Yeah. Behind the cardboard, and see if you can make your witch fly through the cardboard by moving your magnet.
No.
Let's have a little go. Way, look at your witch going. Would you like to have a little go, Anthony?
Yeah.
You may need to move the other witch.
I can't believe she's a witch like me.
What are you going to call your witch, Nimue?
Lisa.
Lisa. It's a very witchy name. She's fallen off a broom.
No, she's just riding upside down.
Well, we're going to leave Nimue and Anthony to play with the witches for a bit and the magnets. You're going to say bye, guys.
Bye. Hi, fun fans. Are you my best friends? Oh, yeah.
Okay.
I am the best YouTuber.
Well, welcome back to Halloween Looks Like This with Homemade Looks Like This and our spooky science.
I'm a student.
We are repeating an old favourite of mine with a bit of a Halloween twist. And today we are going to be creating UV reactive storms in a jar.
Okay.
So this is another simple experiment that anyone can do. And you can also incorporate your geography and your science studies and weather studies, yeah?
Now.
So we're going to be using shaving foam to represent the clouds in the sky. And as we know, when clouds fill with enough moisture, it rains. And this experiment is a fun visual way to show that effect. So, this is a visual way to show the water cycle. When the sun shines, it heats up the seas and the rivers, turning it into a gas, a process called evaporation. This gas vapour is so light it rises into the sky, and once in the sky cools the vapour, turning it back into water droplets, a process called condensation. These droplets then form clouds as the water droplets join together. Once enough drops are combined, it falls as rain, and the rain falls to the ground where the whole water cycle process starts again. So, our first step in this experiment is to take the lids off our jars. You may need to help, Nimue.
I can. Can you take my hand for me?
Good lad.
I'm not coming to you now.
Right, put your jars to one side for 2 minutes. And we're now going to mix up our paint. So you want one little squirt in each plastic cup.
How can you help me open mine, Dad?
Go on, Dad, to the rescue.
Another cameraman. Yeah, cameraman. Camera mum and camera dad.
That's it. Now, using the jug of water. Are you listening, guys? Our jugs of water in front of you. You're going to fill your cups up with that.
Maybe we should hold them while we're doing it. Can you hold it while I'm doing it?
Clever girl, Nimue. That is excellent problem solving. So next step, mix your paint mixtures up using the sticks. So our next step is watering our jars, which we have done. And now we're going to add our clouds on the top of it. And for this, we're using shaving foam. Okay, and to make ours more dramatic, we're going to do it in the UV light. Do you want to clap your hands? Great! So, our next step is to then show the effects of clouds and rainfall. So, I want you to start dropping on the different colours onto your clouds and your jars. There we go, that's it.
You feel right. Are you ready? Hello, I am a doctor. Let me try one of those. Okay, I'll try one of yours. Let's use different colours now. You ready? 3, 2, 1. Ah, it's melting!
Try and do it from the top so you see the effect of the rain dropping down as the cloud swells.
Rain?
Yeah, it'll mimic the rain.
Rain. Rain is the word. Can I try? Look, I need one of mine. I need the torch of mine.
You can share.
Do we have another one?
Well done, Nimway.
Oh. Can I?
Oh, be careful, guys. Yours is looking very funky there, Anthony.
Yeah. Mine too. When I can the rainbow. I'll do the rainbow cloud. Are you do the rainbow cloud? So are you do the rainbow cloud too? Yeah. Okay.
As you noticed, initially the cloud swelled with the colourful liquids and held the liquids inside. Once the cloud had filled with enough moisture, it then began to rain the paint into the water, showing the effects of all the beautiful glowing colours as they fell, swirled and mixed inside the jar. And it creates the most colourful, spectacular storm. This is one of our favourite experiments to do.
Look at my rainbow.
Once the cloud was really oversaturated, huge amounts of rain came down at once. And it becomes a bright, mingled, colourful mess. Which we're all a great big fan of. A spoon! Okay, we shall sort you out with a spoon.
I can save some cream all over my hands. See you tomorrow. Bye. 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 Time to play.
And today we're doing our Wizard's Potion. The Wizard's Potion spell is more commonly known as the elephant's toothpaste experiment. And this experiment uses hydrogen peroxide. So adult supervision is required. You're going to give us a wave, Dad? And yeast. When hydrogen peroxide and yeast are mixed together, it causes an exothermic reaction. Can anyone tell me what an exothermic reaction is?
When the outside of it gets hot.
Well done.
But we were rubbing.
An exothermic reaction is when energy is transferred to or from the surrounding, and it is a chemical reaction. The outside of our containers will get slightly warmer. The yeast helps remove the oxygen from the hydrogen peroxide, which creates tons of tiny bubbles, making lots of awesome foam. And you should see the foam shoot out the top. The foam is just the oxygen, water and washing up liquid that has been added. And the reaction varies depending on size and shape of the container used. And as you can see, we've got 3 different scientific wizard vases. So we put our wizard potion flasks on top of cooking trays to contain the mess to some degree. Gonna give us a wave, Nim? Because with Nimway, it can be quite hard not to make a mess. So, the wizard's potion is a slower reaction than what you'd get with bicarb and vinegar, but this gives plenty more opportunity for scientific observation. Right, should we get started, guys?
I want to add this first.
Just wait. So, the first step is our hydrogen peroxide. Do you want to pick that up, Anthony? Yeah.
I want to.
Okay, be careful. So, because our little flask is a bit smaller, we're going to do about a cupful in there, maybe a cupful and a half. And in the other two, we're going to do half a cup, which is about 125 ml. Do you want to tell them when? So, the next step is 2 squirts of washing up liquid. You can now add your food colouring. And there's 3 colours on the table, so if you do each one a different colour. Yeah, you will see that you have 1 bowl with yeast in it and 1 empty bowl. Okay? Don't touch him, Wayne. Wait. Okay, so in the empty bowl, I want you to add 1 teaspoon of yeast. Add in 2 tablespoons of warm water. Oh, slowly. Right, that'll do.
Don't put any more in.
Right, give it a little stir. It's 1 teaspoon of yeast and 2 tablespoons of warm water. And it doesn't have to mix perfectly. It can be a little bit lumpy, that's okay. Okay, so if each of you gets hold of one of the bowls, so you each have a bowl, there's 3 bowls, 3 of you, and there's 3 vases, okay? You're going to pour them into a vase at the same time as each other.
Okay.
So. And then back away. Ah, Nimios didn't go in.
Wizard's potion.
How can I touch it? What does it feel like?
Have a feel?
Oh my god, it's warm.
It will be warm. Does yours feel warm?
Yeah.
And that is the exothermic reaction.
Now just remember, you can't touch your
face. So we've got to clean our hands after touching it.
You can have a proper touch in it if you want. Just
yeah, just clean your hands afterwards. Should we say bye, guys, while we clean this up?
No, I want to keep playing.
You can keep playing for a bit, but you can say bye to everyone on camera.
Bye. Bye.
So today we are making Halloween lava lamps. Clever girl in way.
It's still banners.
No, it's not.
If it's a total lava lamp, then it's still banners.
No, it's not. Oh, it's not lava like volcanic lava.
Oh, is it pretend lava?
Kind of, yeah. Okay, so today we are making a basic lava lamp which is suitable for all ages, including children younger than Nimue.
Like me.
We tie this activity into our studies on density, and it also ticks boxes for chemistry and physics. A liquid is a state of matter, and we covered states of matter in our earlier video. A liquid pours, blows, and takes the shape of any container you put it in. Different liquids, however, have different viscosity, thickness. One of the things to draw attention to when making your lava lamp is the feel, flow and thickness of both the oil and the water. The oil and water should separate, and this is because water is heavier than oil. A density tower can help to show this perfectly, and we will be doing one later on this week. Liquids are made up of different numbers of atoms and molecules. In some liquids, these molecules and atoms are closer together, which creates a denser or heavier liquid. Right, so should we get started, kids? In your jars, I want you to put water, and you're going to fill it 3/4 of the way. It's probably best if Anthony goes first because it's heavy. Now you're going to add the oil. Okay, you can go first, but you have to do it slowly. Now, how do you think the oil will come out just as fast as the water did, or do you think it will be slower? Slower.
I reckon faster.
You think faster?
How?
Do you think it'll feel like water? Do you think it'll feel different to water?
It feel different to water.
Do you think the oil will feel different?
I touched the oil before.
Okay.
I know.
Right, go on, top it up a bit more, and watch what the oil does. That'll do. Now Anthony's turn. Can you see what the oil's doing?
No. What does it do? That'll do.
Bit more, Ant.
Oh, a bit more.
What does it look like it's doing?
Making a bubble. It's rising to the top instead of sinking to the bottom.
Yeah, it's not mixing, is it? It's sitting on top of the water.
So basically, it's pushing the water down. It's hard. Halfway, the oil's pushing the water down. So when you put your finger in, you're just touching water at the top. But when you put your finger all the way down to the water, it's half water and half oil.
Does it feel funny? Can you tell the difference in the two?
Yeah. Shake it.
You don't need to yet. So the next step is to add in a few drops of food colouring.
You know what it's like? It's when you like get the oily chip.
Ah, yes. Well, it will be. Right, so next step is to add some food colouring. And I want you to watch what the food colouring does too. See how fast it goes in or how slow. See if it mixes. Do you think it will mix with the oil or the water?
The oil's and the oil's on top.
Okay. Right, so Nimwe's had to have a quick change. Give us a wave, Nim. We had a bit of a outfit mishap, didn't we?
And now I am changed in my
Alice in Wonderland costume.
Yeah.
Okay, shall we crack on then? Do you think the food colouring is going to mix with the water or the oil?
The oil.
You sure?
I think it's done with the water.
Well, the water's on the bottom and the oil's on the top.
Yeah.
So which one do you think the food colouring will mix with? The water. Okay, so do you want to pour it in?
I already done mine.
Pour a little bit in. Just a little bit. Yeah, that's enough. Oh, what's it done? Yours has gone funky in way.
I told you it's done in the water.
Look at that. Yours is dropping down like a proper lava lamp. That is so cool.
Mine didn't do
Would you like to try this colour, Anthony?
No, I didn't do that.
Try that colour on your one. Here we go. See, it is now.
And now what we do?
Would you like to add in another colour, Nim, so you have two colours in?
Yeah. Oh, we're going to be full.
That's enough, that's enough, that's enough. Okay, shall we make this a bit more fun?
Yeah.
How do you think we could make this more fun? Yeah, Alka-Seltzer tablet. So would you both like to add in a tablet to your jars? Just one.
Are you ready?
Wait. What do you think it's going to do?
I reckon it's going to mix with the oil. Because the oil's going to slow it down and it's going to stay in the oil.
Oh, you think it'll just sit in the oil?
Hey,
Right, go on then, pop them in.
Oh no, went to the water house.
And now watch what it does with the bubbles. Nim now, just watch for now. Can you see what it's doing? What's it doing? It's got all the oil bubbling up to the surface.
Yeah.
Can you see that?
It's got numbers in.
No, just bubbles.
Oh, look.
Oh, the tablet has a number on. Yes, it does.
What did it say?
It's just the reference number for the tablet, so medical professionals know what the tablets are.
Into the water, it's going up into this oil.
Strange, isn't it, the way it does it?
So we have a number.
Hey? So, let Mummy explain why it does that.
Yeah.
This is a chemical reaction, and we added Alka-Seltzer to ours. And when the tablet combines with the water, they create carbon dioxide, which is a gas. Another state of matter. The carbon dioxide causes the bubbles that you can see. And these bubbles carry the coloured water to the top, where it then bursts and falls back down into the lava lamp mixture.
Can we put another one in?
Yeah, go on.
Oh, mine's broken. But that's
Fine.
That's fine.
They just give lots of different effects. So, look at all the carbon dioxide bubbles they're creating.
Where's another one?
Oh, Nim, yours looks very pretty.
Where's another one in this?
It's in Anthony's. You had one each out of that pack.
Mine just looks like a volcano. Just like
Nim, yours is bubbling up lovely.
You making electric pumpkins?
Yeah, we're going to be making pumpkin clocks.
Who are we talking to? Because no one's holding it. No, we're talking.
We're talking to people who are going to be watching the video when we finish.
So we're talking to our fans.
Oh, fans are they?
Hi, fans. Hi, fans. So this is my mum. This is my mum. This is her first time doing one of our experiments in the seat that we're sitting in.
Clever girl, it is.
So this is my mum's first experiment.
Behind the camera, well, in front of the camera, isn't it? I'm normally behind the camera.
Yeah. It's so more than mum camera.
And as you can see, today we are making our own clocks. And we are using pumpkins. So they each have 2 pumpkins each. I've set everything up in advance. This is what I normally do. I'll set it all up and then call the children in. We're trying a new technique this time where I do all the facts and info behind it before I call them in, just to make it slightly easier. You learn as you go with home ed. So, our potato clock can be used on a variety of veg, and it does suggest trying out different ones. So we've decided to test out our pumpkin theory to see whether it would generate any electricity or not. This is one of the many ways that you can introduce STEM into home ed, by doing experiments like this. And you don't have to be a rocket scientist or anything like that. Anything you don't know, you can learn alongside your children. I absolutely love it. I love getting stuck in and mucking in with the experiments, and I've learnt lots too since we started doing this. So, we bought a kit. We do have wires lying around, but kits are easier for the kids to follow. So for this one, we are using a potato clock kit. I can't even tell you who it's by really. I don't think it says it on it. Does it? Fun Time. So we are using Fun Time potato clock kits. And 2 pumpkins each. Okay. So we'll follow the instructions in the kit in a bit. And I'll be reading them out to the children and helping them, especially with it being electricity. But I will be letting them do a lot of the work themselves as well. This kit uses copper and zinc. The different properties cause tiny particles charged with electricity, called ions, to move between the two strips of metal, which I'll show you later. And that creates a flow of energy known as an electric current. This current is then what makes the clock work. So, how do you get energy from a pumpkin? Very small particles inside the pumpkins help to convert the chemical energy inside the strips of metal into electrical energy. An electrical current moves between the two strips and the pumpkin allows the current to flow. An electrical current then also flows through the wires to power the clock, and each pumpkin works as a device called an electrochemical cell. Now joined by Anthony and Nimue, the White Rabbit and Alice in Wonderland. How privileged am I?
Very privileged.
Very privileged I am, aren't I?
Because you needed us, didn't you?
I do. Where would I be without my little helper? Hey?
Him and me.
Yeah. Do you think we'll be able to make electricity out of pumpkins?
No.
No. Okay. What do you think, Anthony?
Yes, because I need my clock. But if it works, when I'm meant to put the pumpkin, just carry it around and look at my clock.
He's trying to labour the bunny being laboured his stopwatch. That's what he needs to
I
do.
know. I got onto it that time. Nimue,
Just wait.
our first step is a zinc plate and a copper plate. So it's one of your silvery coloured ones, that's your zinc plate, and your copper plate is the orangey coloured one, okay? And then we're going to take this wire, and it's not actually a white wire at all, it's a yellow wire. And we're going to connect it, okay?
Be careful, Mommy.
So we take off these little ends on the end of the wire.
Be careful,
Lens.
Mommy. I'm worried so you don't get bent.
No, it's fine. You take it off like that,
Hey,
and then you thread it through the hole.
Mom, how are you taking it off? I don't want
Just
to.
pull it.
Just pull it. Just pull it.
You can pretend.
Yeah.
So the first stage of what we're going to do today, well, it's a.
I'm going to stop this.
So today's in two parts. The first part is where we have to empty out all the gunk from our pumpkins and turn them into spooky faces. The next part is where we're then going to spice up our usual volcano experiment and do it inside the pumpkin. So it comes out the eyes, the nose and the mouth instead. So let's get cracking.
Yeah.
Right, so let's see your pumpkins. Nimue, what's yours?
Mine is a vampire.
A vampire. Okay, what's yours, Anthony?
No, mine is a zombie.
Well done.
So if you did guess zombie, well done. As you can see the outlines on mine.
See yours then, Anthony. Wow, you can. You can see all the zombie marks. You're turning yours around there. Oh, wow. That is a fantastic vampire, Nimue.
Guys, guess what I
Well
did?
done.
Guys.
So, welcome back. And we're here for the next stage of our pumpkin fun. Do you want to take your lids off, guys?
Yep. Are we doing a start?
We are. In our 3 bowls in front of us, we have bicarb, washing up liquid, and vinegar. You can just see them all there. Yeah, with our pumpkins behind. So the first stage is the powder you're writing with. Do you want to pour half of that powder in your pumpkin?
Yeah. And then I was going to say it's best for me to go first. Will that do? Right, that'll do.
And you pour the other half in yours end.
Just over.
Oh, good lad.
Are you going to pour all that in mine?
And now half the dish soap each. Washing up liquid.
Why? Oh, that's half each. Put all of it in.
Clever girl. Has she got enough in?
I got all of it.
Okay. And now it's the vinegar, and you need half the vinegar each. Okay? But you need to be quick with it, Nim. So let Anthony go first on this one. And then move your hand out of the way.
My turn. Oh.
Is it going?
My turn.
Is it doing it?
It's going up, but not that much.
Okay, right there. Go on, Nim, you'll go.
Is that it?
All of it. Has it come out the back? That's brilliant. Spin it round then, so people can see.
Hey, it's an eye of the...
And Nim, yours looks like it's being sick. Yours has worked perfectly.
It's an eye of the spoon.